Okay, we will start with the fourth type of particular integrals today. This is type 4. So we know that the particular integral yp is given by phi of x divided by f of d. That is phi of x divided by f of d. In type 4, the phi of x will be of the following type, that is some exponential function e to the power ax into v. This will be the format where v is any function of x. For example, this could be e to the power 3x into sine x, e to the power 3x divided by x, etc. So the v will be any different function other than an exponential function. Okay, so the solution goes this way. The solution is the yp is equal to phi of x. I'll replace that as e to the power ax into v divided by the f of d. The solution is replacing the d by d plus a, right? When we do this particular change, when we convert the d into d plus a, the f of t will be converted into either type 2 or type 3. So we use that idea here to convert any given function which belongs to the type 4, where the right hand side of the differential equation given is in the format e to the power ax into any other function of x. Right? Okay, let's go for a simple example. We start with the yp part. We'll solve some questions, then we'll come back to the complete solution. Okay, the first example, let us say that the yp is equal to e to the 2x into sine of 3x whole divided by d square minus 1. So we see that this is in the required format, e to the power ax into f of x, right? That f of x or v is equal to sine 3x divided by f of d. So the solution goes here, replace the d by d plus 2. All right, so this is d has to be replaced by d plus 2. Okay, now that means this is equal to, now the e to the 2x has nothing to do with that. We have taken care of that. That's why we'll write the e to the 2x here into, this is sine 3x divided by, the d square becomes d plus 2 the whole square minus 1. Right, now we can see that when we simplify the d plus 2 whole square and the minus 1 which is after that, we are going to get a complete function which is only in terms of d. Okay, let's do that first. So this is e to the 2x into sine of 3x divided by the d square plus 2 into 2 into d is 4d plus 4 minus 1. This becomes equal to e to the 2x into sine 3x whole divided by, this is d square plus 4d plus 3. All right, now we can see that this function becomes sine 3x by d square plus 4d plus 3. It's just the type 2 question. So how do we solve the type 2 question? Type 2 can be solved easily using this technique. That is equal to, replace the d by, d square has to be replaced as minus of 3. Okay, so let's simplify that now. This is equal to e to the 2x. Now I can see that replace d square by minus of a square, that is minus 9. This means it is sine 3x divided by, this is minus 9 plus 4d plus 3. This is equal to e to the 2x into sine 3x divided by, this is 4d minus 6. Alright, when I have 4d minus 6, I need to simplify this. I need to bring a d square in the denominator. So what I will multiply by 4d plus 6 and divide by 4d plus 6. Okay, so the next step is, this is equal to e to the 2x. We have 4d times sine of 3x plus 6 times sine 3x whole divided by, this is 4 into d, that means 4d into 4d is 16 times d square minus 36. This is equal to e to the 2x. 4 times differentiation of sine 3x is, 3 cos 3x. So 4 into 3 becomes 12. Okay, this is 12 cos 3x plus, this is 6 into sine 3x whole divided by, now I can see that I need to replace the d square by minus 9. So this is 16 into minus 9 minus 36. Okay, so we'll take a 6 out and we'll simplify. This becomes, I can take the minus also outside. Okay, so this final result I'll write e to the power 2x into, this is 2 cos 3x plus sine 3x divided by 30 is the simplified answer. Okay, very similar to this, let us solve a different question. Let us say we have the yp is equal to e to the minus x into, this is 2x square plus 4x plus 1 whole divided by, this is d square plus 5 times d plus 6, right? So this means we know that we have the term, we have to do the synthetic division over here. Let me write the question once again. This is 2x squared plus 4x plus 1. All right, so we have this term with us, and since there is a multiplier, exponential multiplier, that is e to the power minus x, now we are supposed to replace every d by d minus 1. So that's our first step. So replace every d by d minus 1. This means it is equal to e to the minus x into 2x square plus 4x plus 1 whole divided by, this is d minus 1 the whole square plus 5 times d plus 5 times, it should be d minus 1. So 5 into d minus 1 plus 6. This is going to be equal to e to the minus x into 2x square plus 4x plus 1 whole divided by, this is d square minus 2d plus 1, that's the first term, plus 5d minus 5 plus 6. This is equal to e to the minus x into 2 times the x square plus 4x plus 1. Sorry, I need to divide this by, after simplification we are going to get, the first term is d square plus 3 times d plus 2. Okay, all right, so now after simplification we get this, but I can see that now this the term becomes, it can be simplified by using the synthetic division, right? So I can write this as, so let's hold on to this. I can rewrite this as e to the minus x. We'll separate this because this has been taken care of. Then this is 2x square plus 4x plus 1 whole divided by, this is d square plus 3d plus 2. So d square plus 3d plus 2, we are going to simplify the fractional part by synthetic division. Okay, so let's go to the synthetic division first, then the answer will be written after e to the power minus x to get the yp. So let's hold on to this as of now, and we know that the rule to perform the synthetic division is write the denominator in the increasing order of power of d, that is 2 plus 3d plus d square, and we are going to write the numerator as it is, decreasing powers of x, 2x square plus, this is 4x plus 1. All right, so I need to get a 2x square here, so there is a 2 means I need to write x square. Okay, but 3 times differentiation of x square is going to give me a 6x, and double differentiation d square of x square is nothing but 2. All right, so this gets cancelled. So 4x minus 6x is minus 2x. 1 minus 2 is minus 1. Okay, now I have 2 here. I need minus 2x. That's why I'm going to multiply by minus x to get a minus 2x. So 3 times differentiation of minus x will be minus 3. So this will cancel. I have plus 2 coming up. So 2 I already have. So need to multiply by plus 1 to get a 2, which is equal to 0. So which means in 1 I'm going to write the answer as follows. That is, therefore in 1 the yp becomes equal to e to the power minus x, which is already existing there, e to the minus x. I'm going to multiply by x square minus x plus 1. That's the answer. Okay, using this particular technique we can solve the problems which are type 4. All right, now let's go to the situation where we are going to solve the complete problems of type 4. Okay, so the first question is d squared minus 2 times d plus 5 into y is equal to e to the 2x into sin x. Okay, this is already given in the required format. So my first objective is to find yc. So to find yc, we'll write the auxiliary equation. That is, convert the d by m. This becomes m squared minus 2 times m plus 5 equated to 0. Okay, directly we'll find the root. That is, m is equal to minus of minus 2, that is plus 2 plus or minus root of 4 minus 20 by 2. So that means m is equal to 2 and 2 will cancel. This is 1 plus or minus j times 16. So 16 root is 4. Divide by 2 is 2. So 1 plus or minus j2 is the root. So we can compare this with the standard table which we had earlier, right, to find the yc, and it is very clear that it belongs to the third case where the roots are complex conjugates. So whenever we have the roots being complex conjugate, we can guess the yc as this. Yc is equal to e to the power real part, e to the power 1 into x into a constant c1 into cos of 2x plus a constant c2 into sine of the real imaginary part, that is 2x. All right, that's the yc part. Once we have the yc, the next step is to calculate the yp. So to find yp, we'll write the standard equation of yp. Yp is equal to the phi of x given on the right hand side of the equation whole divided by the f of d. Okay, but in this particular problem, we know that the given phi of x is in type 4. That is, yp becomes equal to e to the power 2x into sin x whole divided by, this is d squared minus 2d plus 5. So as soon as we see the phi of x being in the form of e to the 2x sin x, it's e to the ax into v. We understand that this particular problem is a type 4 question. So as soon as we have a type 4 question, our intention is to replace the d by d plus a. A is positive and it is 2 here, so we replace d by d plus 2. Okay, so let us make that substitution first. So this is equal to e to the 2x into sin x whole divided by, this is d plus 2 the whole square minus 2 times d plus 2 plus 5. In the previous step, whatever d we had, we have to replace it by d plus 2. So this is what I'm going to get. Now the role of e to the 2x is over. It has been taken care. Let's deal with only the sin x now. So sin x divided by, this is d square plus 4d plus 4, that's a d plus 2 whole square minus 2d minus 2 into 2 is 4 plus 5. Okay, we got this. Now our next intention here is to simplify the denominator. So that is e to the 2x into this is sine x whole divided by, there is only one d square term here, that is simply d square. Then there is 4d minus 2d, which is simply plus 2d. So 4 and minus 4 will get cancelled. It is simply going to be plus 5. So d square plus 2d plus 5. Now this part is actually a type 2. So type 2 in the sense I need to make sure that I replace d square by minus of a square. So a is 1 here. So I have to replace it by minus 1. Replace every d square by minus 1. That's our objective. So this is e to the 2x. This is sine x divided by minus 1 plus 2d plus 5. Alright, so this means this is equal to e to the 2x into sine x divided by, this is 2d plus 4. Right? What I do, I'll try to further simplify this. E to the 2x divided by 2. I'll take the 2 outside, 2 common, and I'm going to write sine x by d plus 2. So when I have d plus 2, in order to get a d square in the denominator, I'll multiply and divide it by d minus 2. So d minus 2 into d minus 2. Okay, so this is equal to, we observe that this e to the 2x by 2 looks like a constant for us, so we'll keep it out and then we'll multiply. That is, there is d into sine x minus 2 times sine x whole divided by, this is d square minus 4. Once again, my substitution is going to be replace every d by minus 1. So this means e to the 2x by 2 into differentiation of sine x, and capital D into sine x is nothing but differentiation of sine x, which is cos x, minus 2 into sine x whole divided by d square is minus 1 and there is a minus 4. So minus 4 minus 1 is minus 5. Minus 5 into 2 is minus 10 in the denominator. So I can write this as minus of e to the 2x by 10 into, this is cos x minus 2 times sin x. This will be the yp of the given question. So we know how to write the final answer now. So final answer can be directly obtained by writing y is equal to yc plus yp. So yc plus yp, yc already we know that is e to the power x into, this is c1 into cos 2x plus c2 into sin 2x. This is what we had as yc. Now plus the yp should come, which is obtained as negative term, e to the power minus e to the power 2x by 10 into, this is cos x minus 2 times sin x is the final answer. Okay, right. Now let's go to a different question. All right, the next question is, this one, that is d square minus 2d plus 4 into y is equal to e to the x cos x. Okay, so our first objective is to find yc. We'll write the auxiliary equation, that is replacing every d by m. So this is m square minus 2m plus 4 equal to 0. So we find the m by using the standard equation to find out the roots of quadratic equation. So that is minus of minus 2 plus or minus under root, this is 4 minus 4 into 4, that is 16, whole divided by 2. So this is equal to 1 plus or minus, there is a root of minus 12, so I have a j coming up. In the root 12, if I take 4 into 3, if I multiply it 4 into 3, 4 comes out as a 2, 2 and denominator 2 will cancel, so we have root 3. 1 plus or minus j root 3 is the answer, and now we are very sure that this belongs to the third case in the table, and roots are complex conjugates. So as soon as we see the roots are being complex conjugate, we can write the yc as follows: e to the power real term, that is 1 into x, into a constant, into cos of root 3x plus another constant c2 into sine root 3x. Equation number 1. All right, in the next step we are interested to find out the yp. Right, yp can be calculated by taking the phi of x divided by the f of d. Okay, now this is yp can be calculated as, from the given equation, this is e to the x into cos x whole divided by the f of d we just obtained from the given equation, that is d squared minus 2 into d plus 4. Okay, I can see that this is the type 4 question and I'm supposed to replace every d by d plus a being in the e to the power x, a is 1, so this is replace d by d plus 1. Okay, so this means this is equal to, I'll write the e to the x separately now, this is simply cos x divided by, this is d plus 1 the whole square minus 2 times d plus 1 plus 4. So this is equal to e to the x into cos x divided by d plus 1 the whole square is nothing but d square plus 2d plus 1 minus 2d minus 2 plus 4. Okay, we'll simplify the denominator now. This is e to the x into cos x all divided by, so we have only one term for d square, that's here, so we have plus 2d and minus 2d, that gets cancelled, so 4 minus 2 is 2, 2 plus 1 is 3, so we have d square plus 3 coming up. Now I understand that the second term in the product, this is actually once again a type 2 question. So type 2 in the sense replace d square by, look at what is there in a cos or sine with x. So there is 1 over there, it's a square and negative, minus 1. Replace d square by minus of a square. In this case a is 1, so a square is 1, minus of a square is minus 1. Alright, so we obtained that. So this means this is equal to, we write e to the x, this is cos x divided by minus 1, d square by minus 1 plus 3. Alright, in this case we got the answer easily. That is, denominator is simply 2, directly we obtain that. So this is e to the x into cos x by 2 is the yp, and we call it as equation number 2. Okay, so this implies we know that the final answer y can be obtained by adding yc plus yp. Okay, so yc plus yp will be the result. So we'll write that as, from yc, that's equation 1, I'm writing this, e to the x into, this is c1 cos of root 3x plus c2 sine root 3x, and the yp, which is plus e to the x cos x by 2. This is the final answer. All right. Now let's go further to the next question. So the next question is d cube plus 1 into y is equal to 5 into e to the x into x square. All right, now we'll write the auxiliary equation in order to find the yc. The auxiliary equation is going to look like m cube plus 1 is equal to 0. Right, so this is a cube term, so we need to guess one of the root. What I do here is, let's try to put different values. So one of the root I can directly guess here, right? M is equal to, because m cube is equal to minus 1, so minus 1 itself is a root. So first root I am going to guess, m equal to minus 1 is a root. So when I have this, I can actually find out the other two roots by reduction of the powers. Okay, now I have a term containing m cube. So I'm going to simplify that first. That means synthetic division is the technique. We'll write the root here, and the term we'll be writing here. So that is, the term is m cube is 1, no m square, no m, but there is a constant. Okay, all right. So what do? We always start with this 0 here. So 1 plus 0 is 1. This 1 into minus 1 will write here. Minus 1. So 0 minus, it's addition, sorry. 0 minus 1 is minus 1. So minus 1 into minus 1 is a plus 1. So 0 plus 1 is 1. 1 into 1 minus 1 is minus 1, so 1 minus 1 becomes equal to 0. Okay, now we need to multiply in the same fashion. So we earlier had a m cube term. Now I reduce this because I already know one root. So this means this should be a m square term. This should second number should be multiplied with the m, and this is 1. So the coefficients of each of the term we got now. So we will simply multiply and write. This implies m square into 1 is m square. M into minus 1 is minus m. 1 into 1 is plus 1 equated to 0. Now this is the term quadratic equation we need to solve to get other two roots. So we can find it easily by using the formula. This is minus b, that is 1, plus or minus a root of b square is once again 1, 4a into c, 4 into 1 into 1 is minus 4, whole divided by 2. Okay, so this is 1 by 2, that is 1 by 2 first term, plus or minus imaginary term. 1 minus 4 is minus 3, minus is written as a j, so there is a root 3 by 2. So roots are complex conjugates. So now we see we have three roots. Therefore, the three roots are m is equal to, first root is minus 1, and second and third roots are 1 by 2 plus or minus j times root 3 by 2. So we have three roots of these types. So according to the type of roots of auxiliary equation, we are going to write the yc. Therefore, yc is equal to, first root is real and not repeating. Okay, real and distinct. So therefore it is a constant c1 into e to the power minus x. And second and third roots are complex conjugate. That's why we write e to the power, the real part, that is x into 1 by 2, that is x by 2, into, take a constant c2 cos root 3 by 2x is the first term, plus another constant c3 into sine of root 3 by 2x is the other term. All right, so we got the yc directly. Now to find yp, we use the equation yp is equal to the phi of x divided by f of d. So from the given data, we can write the yp as yp is equal to, there is e to the x into 5x divided by, this is d cube plus 1. So as soon as I see that there is a e to the x into some function, that is v, divided by this, it's a type 4, so replace every d by the d plus a, so a is 1 here, this term. Okay, so this means I'll take the e to the power 5, also I can take it out. Okay, so this is 5 e to the power x into, this is x divided by, this is d plus 1 the whole cube plus 1. Okay, now this is equal to 5 into e to the x into x whole divided by, so d plus 1 whole cube should be d cube plus 3 times d square plus 3 times d plus 1, and there is one more 1 over there, so this becomes equal to plus 2. All right, now this term becomes type 3. So in a type 3, we know that we have to do the synthetic division. So let's hold on to this yp as of now. Then we'll replace that. Okay. So to perform the synthetic division, let's go with this. We have the denominator to be written in the increasing order of increasing powers of d. So that is 2 plus 3d plus 3d square plus d cube, and the term I have here is just x. All right. I think there is a x square. My mistake. This is x square. Right. We can do one thing. This is the other technique here. So what we can do, so see there is a 2 to start with, right? If I write a 2 here, then this becomes easy for me. So what I do, I'll make this 2 and I divide this by 2. Okay, so this is the other easier way to get this. Anyway, if there is a 2 common, later on we can cancel it out. So now you see that there is a 2x square and I have x square over there. I can simply write this is simply x square, so that you get a 2x square here. But there is a 3 times differentiation of x square. So that means I'm going to get 2x into 3 is 6. So there is a 6x coming up, that is plus 6x. Then 3 times double differentiation. So 2 into 2 to 3 by 2. So that becomes equal to plus 6. Okay, now this gets cancelled. I have minus 6x minus 6. So in order to get a minus 6 over here, so 2 times it should be minus 3x. 2 into minus 3x is minus 6x. But I have 3 times differentiation of this. 3 into 3 is 9. So minus 9. So this cancels. We have plus 3 coming up. So you have 3 in order to get, you have 2 in order to get a 3, it should be plus 3 by 2. So this is 3, so answer becomes equal to 0. So therefore, we write the yp now equals to, already we had 5e to the x divided by 2. Okay, what I do, I multiply this with the answer just now we got from the synthetic division, that is x square minus 3x plus 3 by 2. So we'll take a 2 outside, we'll make it more simple by taking a 2 outside from the bracket. So this becomes 5 into e to the x divided by 4. The 2 gets multiplied to the first term and the second term. So this is minus 6x plus 3. That is the yc now, yp. Okay, if we have yp like this, therefore we can write the y is equal to, final answer, yc plus yp. So this is equal to, recall we got the yc as a constant c1 into e to the x plus e to the x by 2 c2 cos root 3x by 2 plus c3 sine root 3x by 2 plus 5 e to the x divided by 4 into 2x square minus 6x plus 3. Okay, so that is the answer. Let's go further. Next question. D square minus 4d plus 3 into y is equal to 2 times x into e to the 3x. All right. To find yc. So how to find yc? Yc can be found straightforward by writing the auxiliary equation and solving for its roots. So auxiliary equation becomes equal to m square minus 4m plus 3 equal to 0. So when we solve this directly, we get the roots as m equal to this is m square. If you take m outside, m plus 3, m plus 1. Okay, m equal m minus 3, m minus 1. So this is m equal to 1 and 3. So this means when we find the roots like this, we can write the yc by looking at the roots. Roots are real and distinct. So a constant e to the power first root into x plus another constant into e to the power second root into x. This is the yc. Hold on to this. Okay, next objective is to find yp. So yp is given by the standard equation. The right hand side of the given differential equation denoted as phi of x divided by the f of d. So for this given problem, we can write the yp as yp is equal to the phi of x. We can see that the phi of x is given as 2x into e to the 3x divided by the f of d is simply given as d square minus 4d plus 3. Okay, so this means I can see that the given function is in the type 4. So every d needs to be replaced by d plus 3. So this becomes equal to, we'll write the 2 into e to the 3x separately. This is simply x divided by d plus 3 the whole square minus 4 into d plus 3 plus 3. Okay, so this means we can simplify this further as 2 into e to the 3x into x divided by, this is d square plus 6d plus 9 minus 4d minus 12 plus 3. So 9, 12 and 3 are gone. So this means this is equal to 2 into e to the 3x into x divided by d square. 6 minus 4 is 2. So plus 2d. Okay, now, so what I do, I have to do the synthetic division now because this is what we got as type 3. So I'll include the 2 as well because there is already a 2 available. Let's use that. So this is 2d plus d square and should perform synthetic division with the 2x. So this means 2 times differentiation of something is equal to 2x. So this comes to be equal to x square by 2. So 2 cancels. Differentiation of x square is 2x. Alright, so we got 2x. Should differentiate this twice now. So 2x by 2 and differentiation of the 2 is going, differentiation of x is going to be 1. So this is plus 1. Okay, so 2x cancels, we have minus 1 here. So 2 times differentiation of something should be minus 1. So I need a minus answer, so this is minus. 2 is there, I need to cancel, so divide by 2. So this should be x by 2. I get 2 into 2 to cancel, differentiation of x is 1 and minus 1 outside, so this is minus 1, so answer equal to 0. Alright, so using this, now we can write the yp first. Therefore yp is equal to, we can see that we earlier had the e to the 3x outside should be multiplied with this particular term, that is x square by 2 minus x by 2. So I can rewrite this as e to the 3x by 2 into x square minus x, or even x can be taken out, you can write it as x into x minus 1. Alright, that's the yp. So in the final step, our intention is to write a y that is equal to the sum of yc plus yp. So yc is c1 e to the power x plus c2 e to the power 3x plus another e to the 3x by 2 into x square minus x is the final answer. Next, we'll solve another problem. The question is y double dash plus 2 times y dash plus 5 times y is equal to e to the minus x into sine 2x. Okay, so first we'll convert this into the required format, replace the d by dx as capital D. So I get d square plus 2d plus 5 into y is equal to e to the minus x into sine 2x. Okay, so first what we do, we want to find the yc. So to find yc, our intention is to write the auxiliary equation that is obtained by replacing capital D by m, that is m square plus 2m plus 5 and equate it to 0. So here the m can be obtained by using minus 2 plus or minus root of 4 minus, this is 20 divided by 2. So m is equal to minus 2 by 2 is minus 1 plus or minus, it is root of minus 16, so root of it's negative, so j complex number, root 16 is 4 by 2 is 2, 1 plus or minus j2 are the two roots. So as we can see, the roots are complex conjugates. We can write the yc as e to the power the real term, which is minus 1 into x into a constant c1 cos of imaginary part, that is 2x, plus c2 into sine of the same term, okay, that is 2x. All right, now our intention is to find yp. Yp is given by phi of x divided by f of t. So in this case, I can see that the phi of x is e to the minus x into sine 2x as given in the problem. So therefore, yp is equal to e to the minus x into sine of 2x whole divided by the f of d is d square plus 2d plus 5. So as this is a type 4 question, we have to uh, perform d by d minus 1. So that gives e to the minus x, we'll keep it out, then sine 2x, I guess, sorry, this is sine 2x divided by, this is d minus 1 the whole square plus 2 times d minus 1, this is plus 5. This is equal to e to the minus x sine 2x divided by, this is d squared minus 2d plus 1 plus 2d minus 2 plus 5. So plus 2d minus 2d will cancel. So as a result, we have e to the minus x into sine 2x whole divided by d square. 1 minus 2 is minus 1 plus 5 is plus 4. So I understand that this term is a type 2 question. So as this is type 2, replace the d square by minus of the term, the number which is present inside the sine function, that is it's a square. So minus 2 square, so 4. Alright, so this is equal to e to the minus x sine 2x divided by, now you see this is minus 4 plus 4, which means what? It means I cannot write this answer because the denominator becomes equal to 0. So as soon as the denominator becomes equal to 0, we need to multiply by a x and differentiate the denominator once again of the previous step. So this is equal to, there is x being multiplied, e to the minus x is already there, numerator is sine 2x, no problem, denominator you have to perform the differentiation, d square plus 4, differentiation is 2d. Okay, right, now I need to eliminate the d in this case because numerator is sine 2x, multiply and divide by the d. So what happens is x e to the power minus x by 2. So d of sine 2x is nothing but 2 cos 2x divided by denominator is d square. So here d square can be replaced directly by minus 4. So this 2 and 2 gets cancelled. So denominator is minus 4 now. So this is minus x into e to the power minus x into cos 2x whole divided by Oh, the minus already I have written, so that's why denominator is written as positive. So this is the yp. Okay, to write the final answer, we use the y is equal to yc plus yp. This is equal to the yc we obtained as e to the minus x c1 cos 2x plus c2 into sin 2x minus x into e to the minus x by 4 into cos 2x. This is the final answer. So using this technique, we can solve type 4 problems of solution of differential equations. So in the next class, we will come up with type 5. We'll discuss the theory part and then we'll go for solution of problems. Thank you for watching.